grade 5, are you playing computer games? I know all of you are playing computer games, right? So now you have to come, you must get ready to come to school by next week. So today I'm here to review your science, that is Big Idea 4, week 1. Okay? So time to review a bit now. So please leave all your games aside and come and watch me so that you can review this lesson. So when you come back next week, we're gonna start up a new lesson. Okay guys, are you ready now? Okay, please be ready with a smile. Done. Very good. So here your Big Idea 4 week 1 says, why do we weigh more on Earth than on the moon? I know you haven't gone on the moon, but we know how you're going to weigh on the moon because it is all related to your scientific reasons. So today we learn about a bit of space, that's on moon, and a bit of Earth. Okay, so here you can see, what is this? Earth, our planet, our home, Earth. And we know a lot about it, isn't it? And here, the lovely, beautiful, white circle in the sky. What is that? It's moon. You're right. So we have Earth on the left side, moon on the right side, isn't it? So why did I keep these two pictures on the first? Because we are going to learn about some similarities and some differences between these two. Okay? Get ready. Okay. We learned two terms in the first slide, that is easy words, Earth, moon. Now I want you to say the third term that is related to your lesson. Now you can definitely, you know that he is the great Newton, isn't it? And he is observing something falling down, that is an apple. Falling objects are being pulled down. So, why something fall down? So, can you tell me the term? Yes, you got it right. It is because of gravity, isn't it? Something happened to you, you are walking and there is a rock and you tumble upon that. You are not gonna fly, you will fall down, isn't it? That is all because of the term called gravity. And gravity is there in your Earth, isn't it? So we're gonna talk more about gravity. Gravity on Earth and gravity on the moon. Okay, everybody? Before I start explaining about a bit of gravity and a bit of few more terms like mass, weight, I just want to check how much you remember, okay? Because in the holidays you eat a lot, so maybe you've forgotten a lot of things. So just want to check your memory. So can we read about this? Gravitational force. Gravity is the force of attraction that exists between all objects in the universe. You know what is universe, right? It's not only about our solar system, it's everything. Everything is connected in this universe, all the stars, all the planets, all Milky Way, everything is connected with this great force, that is gravitational force. If you want, you can say gravity as well. Okay, so please read the sentence once again. I'm going to give you 2 seconds to read the sentence. Well done. Okay, so read loud. When I ask you to read, read loud. Okay, dash is the reason we stay on Earth's surface. What is that? Why I can walk on the floor? Why I can't fly? Tell me. Gravity. Let's check. Yes, gravity is the reason we stay on Earth's surface, isn't it? Number 3, the gravitational force on the dash is not as strong as it is on Earth. Can you remember the first slide what I showed you? Earth and the moon, right? So definitely the gravitational force, there is a gravity, but a very, very less, isn't it? So the gravitational force on the dash is not as strong as on the Earth. Let's check the answer. I know you shouted the answer. It's the moon. So read the sentence once again yourself. Good. Now we come to a little bit deeper with the gravity. You can see the first picture, a cute astronaut, cute baby astronaut. He is on the moon, and you can see I have written mass equals to 120 kilogram, isn't it? And weight is 200 Newton. Remember, mass is measured in kilogram. Okay, weight is measured in Newton. Okay, everybody, that is why we say mass is 120 kilogram and weight is 200 Newton on the moon. The same person, if he comes on the earth, okay, mass remains the same. You can see mass equals to, here mass equals to 120 kilogram, and here also mass equals to 120 kilogram, same. Okay, but what about weight? Weight is 200 Newton, and here weight is multiplied by 10 and it gives you 1200 Newton. The weight is on the moon is 200 Newton, and on the earth it is 1200 Newton. Is it equal? No, it is not equal, isn't it? Now we have to find out why is that difference, right? Why the weight is not same, but why the mass is same. So we have to learn about mass and weight definition. We are going to do that, okay? Now come to this picture. You can see the same person on both, right? Same person on the earth, same person on the moon as well. But if you see again, right, 200 pounds, 90 kilograms. if you are very much friendly with the kilogram, he weigh 90 kilogram. But when he go on the moon, naturally he weighs only 15 kilogram. My God. So you are going to weigh 6 times more on the earth. Or you can also say otherwise, you can weigh 6 times lesser on the moon. Like for example 90, isn't it? 90 divided by 6. Right? 15 kilogram. Wow. So you remember that you weigh 6 times less on the moon. Suppose if you are weighing 60 kilograms, then how much you are going to weigh on the moon? Yes, you're right, 10 kilogram. That's right. So you can see now the time to see. Now the time to see the arrow mark. Carefully, because it's not just arrow mark, it is going to tell you about the amount of gravity. You can see a thicker line here saying gravity, and you can see thinner line saying gravity, isn't it? So that tells you a lot. Thicker lines means more gravity on the earth, less gravity on the moon, and more gravity and less gravity is the reason that you weigh different on earth and moon. Are you following me, guys? Good. Now we come to the definition. Okay, everybody? You can see here mass versus weight. Means what is the difference between mass and weight? Let's have a look. Mass is the amount of matter that makes up an object. The amount of the matter within an object or within the body, we call it as mass. Guys, can you see? Mass is the amount of matter that makes up an object within. And what is weight? Weight is the measurement of the force of gravity. Very important. Weight is the measurement of the force of gravity on an object. Or you can just say weight is the gravitational pull on the mass. So weight is nothing but when there is a gravitational pull is there, there will be a weight. And since Earth has more gravity, there is more force, and that is why you weigh more. Okay? Number 2, mass of an object does not change. Mass of an object, you go anywhere, will not change. But whereas weight change, isn't it? And how weight is measured, do you remember? Weight is measured in Newton and mass is measured in kilogram. Very good. Okay, everybody? Now let's smile at this slide because it's a very funny one. Right? Look at that. Ooh, Great. I can lose weight without doing exercise. Why? Because if you're weighing like 60 kilogram and you go on the moon, you're going to weigh just very less, isn't it? So you feel like, wow, I'm so thin and I'm so lightweight, isn't it? So here, mass, weight and gravity. How these things are related? If you find the weight of something on earth and then take it to the moon and weigh it again, you will find that it is lighter when it is on the moon, right? It is lighter on the moon. This is because the only reason is surface gravity. Surface gravity is higher on the earth and lesser on the moon. Okay, everybody? Are you there? Okay, so here, weight, I'm stressing on the word weight now, okay? Because sometimes you get confused with the mass and weight, so I'm stressing on those two terms quite a lot. Weight is the word we use to describe how heavy something is, isn't it? Like for example, if I want to ask you how much you weigh, that means I want to know that how heavy you are, isn't it? So Earth's gravitational force causes objects to have the weight. Focus on the term. Earth's gravitational force causes objects to have the weight. If there is no gravity, maybe you don't have the weight. Okay? Can you read this for me? Gravity is a force that pulls object towards the center of the earth. That's why we have shown you. You know, if there is a ball on this somewhere, it has to fall down, isn't it? So it is showing you that it is falling towards the center of the earth. A simple differentiation, if I want to show, mass is the amount of matter in something. You can say something as, you can also say something can be an object. Okay? Weight is the gravitational pull on a mass, and that is weight. Now, maybe it's a bit not so clear, but I can read for you. If you weigh 100 lb on Earth, you would weigh, I have some planets and moon here, 17 lb on the moon. Okay, 17 lb on the moon, 38 lb on the Mercury, okay, and 91 lb on the Venus, 38 lb on Mars, 253 on Jupiter, right? 38 on Mars, 91 on Venus, 107 on Saturn, and 91 on Uranus, and finally 114 on Neptune, right? So if you weigh 100 lb on Earth, you are weighing different weight on different planets. and that is just related to you're right, gravity. So now I have a question based on this. Which planet exerts strongest gravitational force? Right? You have learned about it, right, guys, here? Now, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and how much you weigh. So this is a different question that I have asked you here related to that. Which planet exerts strongest gravitational force? Where there is more gravity, right? So in this one, you are weighing more on Jupiter. So your answer is Jupiter, right? Good. On which two planets is gravity the weakest? Of course, in which of the planet you weigh lesser, it is gonna be the weakest, isn't it? So what's your answer? Okay, let's check it out. Mercury and Mars, right, everybody? Okay. Now just a bit of review, guys, everybody. Remember, important, gravity describes the pull between masses, right? Gravity is nothing but a force. Okay, you have mass and Earth has mass. There is a pull between you and the Earth. That is why I am walking, otherwise I would have flew. We measure this pull with a scale, isn't it? For example, we weigh ourselves and say, oh yeah, I am 60 kg, I'm 70 kilogram, right? So we use the scale. The more the gravity, the greater the squeeze on the spring. Means the more the power of the pull, you are weighing something with the spring, the more pull it is, and it is going to squeeze on the spring of the scale, and the more you weigh. Suppose you take an apple on the Newton scale and you put the apple and you see, okay, an apple weighs 50 gram. And if I take a heavy book and weigh, the spring pulls more, isn't it? Why the spring is pulled more? Because of heaviness, because of the gravity. So squeeze on the spring. Do you understand that term? And now we learn about the difference between mass and weight. We also learn about how your mass is measured on the moon and how mass is measured on the Earth. And mass on Earth and moon, the same, it will not change. But whereas the weight on the moon and on the Earth, weight is not same, or it change, isn't it? So all of these terms we learn in your big idea for week 1, isn't it, everybody? I hope now you remember everything. Okay, so I wish you a great weekend and also hope to see you on Monday. Okay, everybody, bye.